Howdy, y'all. Welcome to another one of my aviation weather videos. This is the third video when I'm talking about water vapor. And so I'm Dr. Andy Molter. I'm a CF5, CFII, MEI. I'm a former corporate pilot, and I'm a professor of aviation. So I used to, one of the classes I teach at my university is aviation weather. So these are the same class, these are all the same lectures that I give to my students. So you're getting them for free here on YouTube. So make sure to subscribe so you can stay tuned for the future videos on aviation weather and all my other aviation videos. All right, so I'm talking about the change of phase of water vapor. And so water changes from one state of matter to another at the temperatures and pressures experienced near the surface of the Earth. And so going from a solid to a liquid, or a liquid to a gas, or a gas to a solid. And so water has unique thermal properties which make it a powerful heat transport mechanism. And so if you saw my previous video talking about heat and temperature, all the different, elements out there, or all the different, substances, they have specific heat capacity. So if you haven't seen that video, go back and watch it. And water has the highest specific heat capacity of any naturally occurring substance. And so one term you want to know is latent heat. So latent heat is the quantity of heat energy either released or absorbed by unit mass of a substance when it undergoes a phase transition. So whenever water melts, it's going to either absorb or expend heat, and we'll find that out in a second. So heat is exchanged by water and its environment during the phase transition. And so here, we have different forms of change. So of course we know when snow goes to a liquid, we call that melting, or when water goes from a liquid to a vapor, a gas, that's evaporation. Or when water goes from a gas, water vapor, to a liquid, that's condensation. So think about, you have like a cold glass of water or lemonade or beer. Um, you're out in the heat, and it's a cold drink, then that water vapor in the air is going to condense onto your glass. Or you stick a water bottle in your freezer, well, it's going to freeze and turn into ice. Well, there's two more that you probably didn't know about. It's deposition and sublimation. So deposition, that's where water, starts out as a gas and it completely bypasses the liquid stage and goes straight to a solid. So a good example of this, you wake up in the morning, it's winter outside, and you see frost on your fence, your metal fence post or something like that, or on your car. So that's where water vapor turned directly into frost. So snow is another, form of that. It's water vapor that turned directly into snow. All right, then we have sublimation. So sublimation, that's when a solid goes directly to a gas. So if you've ever seen outside in the winter, not in Texas because it just melts, but you'll have snow out on the ground and then it just disappears. You never see like a melting stream of water. It's just snow on the ground or ice, and then it just disappears. That would be sublimation. Now, one thing I want you to look at on this chart is the different colors of the blue and the red. So red represents the absorption of latent heat from the environment, and blue is the release of latent heat to the environment. So let's talk about the absorption of heat. So whenever you have snow that melts into water, it is going to absorb heat. Same thing when the liquid water turns into a water vapor. And so a good way to think about this is, you're outside, it's hot outside, you start sweating. Well, as that sweat evaporates, it's going to, because it's latent heat, it's going to absorb heat from your body to help turn it into that water vapor to evaporate into a gaseous form. So that's why the sweating actually cools us down, is because as the sweat evaporates, it's absorbing heat. Now let's same thing. So if it's snow on the ground, and whether it melts or it sublimates, well, if you're around that snow or ice, it's actually going to be warmer around that area as it's sublimating or as it's melting. All right, and then we have the release of latent heat to the environment. So let's say you're standing outside, it's really humid outside, and so I just made a video on relative humidity. So if you haven't seen that, go back and watch it. But let's say it's really humid outside and there's a lot of water vapor in the air, but as you're standing there, you can just feel that heat. And it's because now maybe you're not so cold that it's condensing onto you, but you are probably going to sweat and probably it's going to be helped by the condensation of water vapor. And so as water vapor condenses, it's going to release heat as it's turning into a liquid. And so even though it may only be in the 80s, if you have a really high humidity and you're getting a lot of condensation, well, that just the phase transition of going from a gas to a liquid, that is releasing heat, and that's why you're feeling even warmer, even though the temperature may not be that high. So same thing, when you have liquid water that turns into ice, a solid, it's going to release heat so that it can make that transition. All right, so if you haven't seen the other videos, maybe you won't be able to answer all these questions. So make sure you go back, watch part 3A and 3B, talking about water vapor. And so, what is water vapor? Can you answer that question? What is transpiration? What is sublimation? What is infiltration? At what point does saturation occur? So try to answer these questions on your own. If you can't, go back and watch those videos. All right. Well, if you have any questions, leave them down in the comment section below. I'll be happy to answer them. And please like and subscribe. You have a great day. Take care.